Dear friends, in this video, we will look at hypothesis testing for bivariate population proportions. An interesting example is going to be discussed with you, and I hope you will get good insights. Let's now see the problem on hand. Which advertisement is better? Tom, advertising manager for a frozen foods company, is in the process of deciding between two TV commercials, X and Y, for a new frozen food to be introduced shortly. Commercial X runs for 20 seconds and commercial Y runs for 30 seconds. Therefore, for a given number of exposures, commercial Y will be more expensive than commercial X. Tom believes commercial Y will also be more effective in creating awareness for the new product, but he's not sure. Each commercial was recently shown during the same TV program, but in two comparable test cities. After the broadcast, a random sample of 200 adults were interviewed by telephone in each city. In the city in which commercial X was shown, 40 out of the 200 respondents were aware of the new frozen food. That is, the awareness rate for commercial X was 20%. In the other city, the awareness rate for commercial Y was 25%. Can Tom conclude that commercial Y will be more effective in the total market for the new frozen food? A very interesting problem. Based on the sample, one is tempted to conclude commercial Y is better because you are getting 25% in the test marketing, which is better than 20% for commercial X. But can we conclude that it is the same in the population proportion with a 95% confidence level so that we can conclude commercial Y is more effective? We will have to do the test of hypothesis, and let me proceed. Structuring the null and the alternative hypothesis, H0 the null, H1 the alternative. Status quo is the null hypothesis. P2 equal to P1, capital P2 is equal to P1, I mean, capital P2 less than capital P1, where capital P1 represents the proportion of people who were aware of the new frozen food in the population when ad X was used. P2 represents the population proportion of people who were aware of the frozen food when ad Y was used. Now, if we reject the null hypothesis, we conclude the alternative is true. In other words, the alternative says P2 is inferior to P1. That's the one-tail test. Whereas we want to say P2 greater than P1. Actually, there is a typo here. We should do this as P1 greater than P2. This should be the one. In other words, if the null hypothesis is accepted, then we cannot conclude that P2 is better than P1, that is, ad Y is better than ad X. But if the null hypothesis is rejected, then P1 is inferior to P2, which means P2 is superior to P1. That is the conclusion. Okay? So let me just go ahead with the test. The test statistic that is used is Z is equal to P2 minus P1 under root the denominator P into 1 minus P into 1 upon N1 plus 1 upon N2, where N1 is equal to 200, N2 is equal to 200. And P on simplification is 0.225, which is computed by this formula. P is equal to N1 P1 plus N2 P2 by N1 plus N2. Okay. Now, small p1 is used here because the test statistic is based on the sample proportion. So small p1 represents the sample proportion of people when add X was used. Small p2 represents the proportion of people who are aware of the new frozen food when add Y was used. So the numerator equal to is Z 0.25 minus 0.20, 0.05. Denominator is on simplification 0.0418. 0.25 is P2. As you know, in the previous slide, you can see 25%. Okay. And numerator, denominator both are known. So Z stat, therefore, Z stat computed equal to 1.197. The critical Z for the one-tail test for the confidence level of 95% or alpha equal to 0.05 is 1.645. Therefore, the null hypothesis is accepted for want of evidence. So you cannot jump the gun and conclude that commercial Y is more effective than commercial X. You need to do some more test runs and improve perhaps your acceptance rate of the ad more than 0.25, which means at the current level of alpha 0.05, we have no evidence to reject the null hypothesis. In other words, it is accepted. Both the ads are as effective as each other for want of evidence. And that is the beauty of a wonderful practical problem solved by testing the hypothesis of population proportions for the bivariate case. Thank you very much. We will see you in another video soon.